Hi everybody, this is your captain speaking. As the only skeleton crew member with actual flight time logged, I am seizing control of this video. Anyways, I am seizing control of this video for real, not because of flight reasons, but because we are talking about an animal today that I have spent an ungodly amount of time thinking about and working on. I have seen 165 of these specimens firsthand, photographed, measured, thought about every day, every night. It's all Tylosaurus. Jesus. Anywho, my name is Amelia. I'm a PhD candidate at the American Museum of Natural History.
My name is James Napoli. I'm a postdoctoral researcher at the North Carolina Museum of Natural Sciences and North Carolina State University. And for the first time in many videos, I've left off my hard-earned prefix, which is doctor. And I'm not going to let anybody forget it for at least one more year.
Hi, everybody. My name is Scott Johnston, and I am the vertebrate paleontology fossil preparator and technician at Harvard University's Museum of Comparative Zoology. And I will be very much playing the role of a preparator today, in that I assisted one of our members in working on one of these animals a little while ago.
The one and only.
The one and only.
I'm Alex Rubenstahl, a PhD candidate at Yale University, and I would like to say that I have also helped today's leader in working on one of these animals, but unlike Scott, I'll get a authorship acknowledgement for my work.
It's fair. It's not.
It's not really. I don't know about that, but
You've got more work.
I have benefits, so,
Yeah.
all right, you get paid.
I'll be okay.
I
do get paid.
You have fulfillment and benefits.
I have sadness and an H index that will do this.
I'm Dalton Meyer. I'm also a PhD candidate at Yale University. And like many members of the crew, I too assisted our captain in studying these animals. I showed her around the catacombs of the collections, and I wish only to return to the cave in which I should be dwelling, instead of being forced out into the light.
Well, you will also get authorship for Mosasaur help. Whenever I get to cleaning up that scan that I promised you, you could help me with.
This also, yes. Take your time.
It's not up to me.
And together, we're the skeleton.
We're the skeleton
Crew.
And I guess, yeah.
All right.
And it's cool that Amelia flew a plane.
That is cool.
Yes, I've actually logged. It was part of a. There's a program back home. I'm sure it's everywhere. Through the Experimental Aircraft Association, where local pilots will just donate their time to take kids up in airplanes.
Oh.
And because I was on the older end, and actually my plan A for jobs was to be a pilot, they let me fly the planes. I've taken off and I've flown a plane, but I've not landed because that's too risky.
Should we, without further ado, bring some of these bad boys into the world?
What you do?
Yes.
They are indeed bad.
They're so bad. I love them, though.
What you gonna do when they come for you? Bad boys, bad boys. What you gonna do? Oh my goodness, Amelia. You know what I just noticed?
What?
About this boy swimming onto the scene?
Yeah.
As viewed underneath, the ventral aspect of its body looks quite like the ventral aspect of some vomers.
Oh my god.
Do you see? Do you see the folds?
The wrinkles of the
yonic folds.
This is an extremely yonic animal.
Oh my god, that's not. Oh lord, so this is. This it started as a bit that these are yonic animals, and it's like the more of the anatomy that I find of these things, it's like I didn't even send it to you. There's a photo I'll send later of another one. It was another Tylosaurus. It was parietal. They're very yonic animals in many aspects of their anatomy, which is very funny. We discovered this working on the holotype and genotype, which is the specimen that Scott helped me with at the MCZ. MCZ 4374, the holotype of Tylosaurus horriger. Yeah. I
mostly just lifted things. It's very heavy.
It is very heavy.
So Scott, would you say this was your role? What's happening on screen
This
right
is
now?
me.
Scott.
Yeah.
Scott is a sky crane carrying a Tylosaurus.
We have Yeah, we're gonna get derailed here a little bit, but we'll come back to the palates. But actually, those aren't the vomers. That's actually the premaxilla that's doing that. That looks that way.
Wild.
So in these animals, there are several parts that are yonic. We look the word up if you're so inclined. I'm not going to tell you.
No. I'm going to tell them what it means.
You can tell them what it means, but okay. First, let me get through this little bit of anatomy. It's the ventral aspect, so underneath the premaxilla, which is the front part of the snout, which we'll get back to later because it's important for these guys. The ventral again. Aspect of the frontal, and anteroventral parietal is the other photo that I haven't sent you guys because they've got the parietal frame in there and there's like some ridges and things up there, and I just saw it out of the corner of my eye when I was working on it. I was like, oh, another one.
So for anybody in our audience who hasn't already Googled this word, yonic is the distaff counterpart of phallic. So if you know what phallic means, which if you're on the internet, I bet you do, yonic is the female equivalent to that.
It's really appropriate that we have Tylosaurus in here with Styxosaurus, in that we made so many of those jokes about Styxosaurus in that episode.
I love that.
Oh,
I haven't actually... I have a secret. I haven't actually watched any of the new animations because I haven't played this game in a while. Scott, you wanted to tell us what the name means.
Absolutely. So this is Tylosaurus, oh no, this is not a good segue into the name.
It is a good segue. Yes.
Tylosaurus means knob lizard, in contrast to what we were just talking about. But it is in reference to not that, you weirdos. Get your mind out of the gutter. Especially you. But it is in reference to, and the you is mostly directed at most of the crew.
That's slanderous.
I had a joke that was like half put together, but I'm not gonna finish it because no, it's bad. And I don't even know where I was going with it.
Well,
so, okay, the term knob lizard is in reference to its...
Knob,
and by that we mean the extended bulbous front part of its nose there, which its species name, which we'll get to which species this almost certainly is in a minute, but the type species is prorigger, which I remember having a conversation with Amelia about how I hated that species name and I thought it was very bad, until she told me that it actually is, again, in reference to its nose, and it translates to prow bearer, which I was like, okay, that's actually like pretty rad.
It is.
So it's the knob lizard with a prow.
Prorigger always makes me think it's a weird name and it's appropriate, but it also makes me think of like someone who works on a sailing vessel and like, this is a pro-rigger. Like, this is the master of the sails and the knots, and it's of the sea. So it works in many ways.
Yeah. I really like this name as a throwback to when like a lot of paleontologists had a really, really thorough versing in Latin and Greek. And there were a lot of names that came out of them that just don't emerge now because like they knew a full vocabulary. Like, you're not going to get this stuff if you just plunge it into Google Translate and you're like, what does this mean? Like, not that that's lazy. We don't learn Latin and Greek in school anymore, unless you're me, in which case you do learn Latin, but not Greek.
There's a reason the name is redundant in the way it is that it's had its name changed at least 3 times. I have the Mosasaurus / Kansas Bible here, so I'm going to double check to make sure I don't get it wrong. But the original one, I know the original name. It was a Macrosaurus prorigger, so big lizard with a prow. Like, that makes sense, and that's actually a pretty good name, but Macrosaurus was preoccupied. So after that, it went through... Oh, you're actually... No, it's not going to tell me what it is. It's in here somewhere. I'm not going to dig through it and lose my mind, but I believe it's also after Macrosaurus. It was literally a Cope and Marsh battle, and I believe Marsh won eventually, because Tylosaurus is his name, isn't it?
I believe it is.
I believe so as well. It was Macrosaurus by Cope first, if memory serves. Yes.
Cope was first, and then I believe Tylosaurus came. Yep, Tylosaurus is Marsh. So 3 years after, it was first described in 1869. And then a couple years later, it became Tylosaurus. So it went through, first it was Macrosaurus, and then I forget the order of the two, but at one point it was Liodon, and at one point it was Rhinosaurus.
That's the order.
Yeah. Mm-hmm.
Okay,
Yeah.
Liodon first, and then Rhinosaurus. Liodon was an existing mosasaur genus from Europe, I believe, based on teeth. And that's a recurring theme you will notice in videos about mosasaurs, is that their taxonomy is a disaster. Through no fault of their own. They've been around in scientific study for as long / kind of a bit longer than dinosaurs. Mosasaurus was named about 20 years prior to Dinosauria. So because of that, and because they were the target of the bone wars in a lot of ways, because a lot of them are from the American West, they've got this really complicated taxonomic history. So Liodon may or may not be a real thing, but if it is, it is not Tylosaurus.
It's a good name. It sounds biblical.
It is. Yeah, it might be a mosasaurine if it is real. But I don't really know the status of that. That's something that I think there's some scientists in Europe. I think it might be Natalie is working on that.
So sorry,
in Paris. But anyways, and then so the names went back and forth. The next one was Rhinosaurus, which is nose lizard. That was already taken, I believe. And finally Tylosaurus, because especially in Prorigor, so it's called the rostrum, the premaxillary rostrum. This is an extension of bone that goes beyond the front teeth. So in Mosasaurus, the teeth go almost all the way to the end. They actually have a tiny rostrum at the end there. In Tylosaurus, and this skull that I have is actually, it's a little hard to see, but they stop. They stop well ahead, or well behind, the tip of the snout. And in Prorigor, the snout actually does become kind of inflated like a doorknob. Like it's not just a smooth thing. That's something that would distinguish Prorigor from some of the other species. Prorigor and the later species. There tends to be within the Tylosaurines, which are Tylosaurus and its buddies, there tends to be this like pattern of like getting thicker, more robust snouts as the lineage progresses. Not that it's like anagenesis really, but like there's a trend in body size and robustness and meanness of these things as they got bigger. So yeah, that's what the name comes from. It's an interesting piece of anatomy that we're still not entirely sure what it was for. It was probably at least in part sensory. It's got a lot of little pits on it that nerves and other vessels could go through. But you probably, if you are involved in the paleo community, have seen a hypothesis that these things were ramming each other with their snouts like that. Perfect timing.
So you're saying
that's not something. Yeah,
you're saying they could be ramming each other while they were attempting,
they could be ramming each other with their knobs. Yeah. So for a while, it was thought that that's what they were doing with this knob because it doesn't look like there's much variation between sexes. Like we've got like I said at the beginning of this, I've seen almost 200 of these things, and there does not at this point seem to be a strong pattern of some of them have short ones, some have long ones, so it's sexual. Like that doesn't there doesn't seem to be a strong pattern of like some are short, some are long, which is what you would expect to see if this was like a sexual dimorphism thing. There is a slight species signal. So like I said, like at the later species tend to have longer rostra relative to the whole skull. So like Tylosaurus diplodocus, which is an earlier species, has not even much, but a proportionally shorter rostrum than Prorigor and the later Hanosaur morphs. I say morphs, but whatever. The later Hanosaur ones do.
So directional evolution.
Sure, yeah.
Can I ask a question at this juncture?
Yes.
They're all in like interior seaway, right? Sorry, James, just let.
No.
They're not. Okay, but Tylosaurus are from the Western Interior Seaway?
If you agree with Hanosaurus being distinct, then Tylosaurus is strictly North American.
Okay.
If you lump Hanosaurus into Tylosaurus, then no, they're also in Europe.
And they're from like the Campanian or the Maastrichtian? Or like before?
Santonian.
Santonian's Campanian, right?
But there's like a range.
Turonian.
Oh, wow.
Yeah, I think the earliest ones are like late Turonian.
But they're like from when the water temperature is really high, right?
Yeah.
Okay, cool. And then you're saying as they evolve...
Alex,
The
you
rostrums
need to
get
stop.
shorter.
You have to stop.
As the ocean's cool.
That's actually not what happened because they got bigger.
Is it a shrinkage type?
Alex,
No, it's not a freaking situation.
All right, last one.
I
Sorry.
have to edit this episode, so I demand. I simply demand
Cease and
you to stop.
desist.
Okay,
You've been issued a cease and desist.
that was the last one. Probably not, but
I'm gonna. So, Amelia, can I ask a question at this juncture?
Yeah.
Okay.
Yep.
So you mentioned the neurovascular, like sensory, or the potential that they're like a sensory structure because they've got a lot of neurovasculature. How much does that differ from other mosasaurs in terms of the amount of neurovascular stuff there? I asked this question because in theropods, there's a tendency where people notice how highly vascularized the maxilla and the premax are. And there are repeated suggestions that there's like a functional specialization of these areas for like high sensitivity. Whereas to my knowledge and understanding, it is a fairly normal thing for a lot of the neurovasculature to be concentrated in the maxilla and the premax.
yeah, it's worth.
So like, are these showing like an abnormal degree of that, or is it like just fairly normal?
From my like off the top of my head, yes. Like
Okay.
there's a difference which we could tie this into a little bit of mosasaur systematics, like in-group systematics. So there's which we'll come back to later when we're in the phylogeny part of the episode. But like basically, there's 3 different groups of mosasaurs. 4 if you count halosaurs as their own thing. We really don't know what's going on with them. But all the snouts seem to have kind of slightly different shapes and numbers and arrangements of the foramina on the tip of the snout. So in Tylosaurus, there's a whole bunch of them. They go all the way around the rostrum, with the exception of like a little bit ventral. There's nothing on the ventral, but they're on top and on the sides and all that. And there's just like more of them, and they go kind of like farther back up on the snout versus like Mosasaurus and Cladastes, they're more concentrated up front. And in Pliopletycarpines, they don't they have like this
What's the
really definitive pattern.
what's the density
where
like?
it looks like domino dots. Density is
Like compared to like an alligator or a croc or something, where there's like
Oh, they're not that dense.
Okay.
Like they do not look like gators, which is interesting. Like they're not like pocketed like that at all. Like
Right. Well, with gators,
That makes sense to me.
Yeah, well, gators it's an apomorphic sensory organ, right? It's the ampullae of Lorenzini are
yeah,
I
and,
think
and there's,
unique
there's
to
a very
crocodilians.
there's a pretty obvious like stepwise
What?
acquisition
Hang
of
on.
like density as
Are they also called the ampullae of Lorenzini and crocodilians?
no, that's in sharks, right?
That's
no,
the sharks.
did I use the wrong term?
Yeah, I was just
Sorry.
Sorry, I didn't even catch you.
my mind was blown for a second.
Sorry. What are they called in alligators? I thought
Because the ampulla, the ampulla of
Alfredo of
Lorenzini is
linguine.
like a very specific kind of like jelly set thing.
Oh, so they just call them integumentary sense organs. They also appear to have chemosensory function.
Yeah. And so I'm looking
Yeah.
at the genotype right now, and the other thing that's unique with Tylosaurs, because they have a blunt, like it's blunt, like the rostrum is blunt. It's like a doorknob, right? Like almost literally. They have foramina that are like on the front of it, which in other mosasaurs which have these like pointy little snoots, they don't have that real estate. What are you doing in this chat? Knock it off.
Alex, please.
I wasn't gonna say it in the video, but
No,
It's
but stop.
distracting.
It's funny, but yeah. But anyway, to actually circle back to the entire point here. Even though some people think that these things might have been ramming each other with the knobs, it's unlikely, in my opinion, given how sensitive they were, that this would have been something that they liked to do. But that's not to say that they didn't do it, because like that's behavior. Like that's something that we very rarely can actually have a concrete yes or no answer for in the fossil record. Even in specimens that like look like maybe they have blunt force damage to them, which we'll talk about that specimen in a little bit. And it's not the one you're thinking of, because there is a paper that talks about ramming in Tylosaurs. It's it's one of the Belgian ones, so this would have been Tylosaurus or Hanosaurus bernardi, which is the European species. And the skull, it's one of the Mosasaurus skulls. I believe it's the one that's one of the ones on display in the Brussels Museum. And this was written by Lingham Solier in 1990 something. I'm blanking on the exact number, but he was looking at that skull and he's like, wow, the brain case is in pieces. It must have been like broken apart by something. Oh, a Tylosaur could have like broken through the temporal opening and busted open the it's like, no, because there's soft tissue and muscle. Like there is so much muscle in here. No, like they're strong. They're not that strong.
About how large would the exit wound on a animal be after a Tylosaurus just shot through it like a bullet?
I don't know, but anyway, so that paper is kind of like, I wouldn't necessarily trust it because what he's calling blunt force trauma is like taphonomy, and the fact that the animal died and kind of fell apart, because that's what animals tend to do when they die. Especially like a structure like the brain case is protected by a lot of soft tissue that's really strong, and also like those bones are really tightly sutured together in these things, and like commonly like in collections, like that's a chunk of the animal that's actually still all together. Like a lot of the other bones kind of fall apart, they disarticulate because they're not as tightly sutured together. But usually mosasaur brain cases, at least a lot of the time, tend to be in a big block.
I recall.
Also, like, if it were blunt force trauma, it wouldn't just pop the brain case apart at the seams. Like, if you get blunt force trauma, the bone will break.
Yeah.
Listen, when people get into car accidents and they have head trauma, that's a bad thing. But the human skull does not pop apart into a perfect anatomical preparation along the suture lines.
No. It happens just like... No, it's just like when a character dies in a Lego game. they just they make that little like brick falling noise.
Yeah. One thing that I was just thinking about is that I think it's also like worth noting, like finding a little bit of pathology on an area does not mean that it was routinely used for this function. So today, skeleton crew viewers, today my day consisted of waking up, driving for 12 hours from New York to North Carolina after the holidays, sitting down in my chair and immediately starting to record this episode. So I am tired, but I did something very embarrassing.
Look at what we sacrificed for you.
In New Jersey, I was at a gas station. And it's the scariest gas station I've ever been in. I pulled up, I asked the attendant, because it's in New Jersey, so there's a guy there who has to pump the gas because it's a threat to life itself to let a human being pump their own gasoline.
Are you saying that gas station attendants are not human beings?
Well, no, but they are human beings, but normally there's not gas station attendants, is what I'm saying.
No. They're not human beings because they're in Jersey.
Right. Anyway... viewers from New Jersey, we love you.
But we don't love your gas stations.
Anyway,
don't hate it.
I pull up. I say to the guy, what did you say, Alex?
Oh, I just don't hate I don't hate the attendant.
I love it. No, I mean, I don't hate it, but it's relevant to the story because the man witnessed something very embarrassing. So I have to pull up and ask him, I'm like, do you have a bathroom in there? He's like, yeah. It's, inside to the right. I pull over. I walk up to the place. I go in through the door. To the left, there is a basically abandoned countertop with nothing on it except an old cash register that looks like it's from the 1970s. In front of me is what used to be a display rack for buying snacks and drinks, but is completely empty, except for a carton of eggs that has dried, decaying egg just stuck to it. Now, at this point, I really have to pee, so I'm like, I'm going to deal with this in a moment. I go to the bathroom, which looks like it's probably where they filmed the bathroom scenes in Saw.
Hey, I recognize that joke from earlier today.
It is the scariest thing I've ever seen.
Do you think...
What?
Do you think they were planning a mob-style hit there, and you showed up maybe like a few minutes before the guy that we're waiting for? Oh, yeah, sure, let him pee.
It's very possible.
He'll be out of there. He'll be in and out.
Yeah. Tommy will be over here in about 15 minutes. So I go to the bathroom. I walk out and have this immediate sense of dread and fight or flight over me of like, I need to leave, which bolsters Alex's point. I run out of the bathroom very quickly. Yeah. I go out of the building. I try to move quickly back to my car because I'm like, I just want to go. And also I don't want him to make me buy gas because I don't need it. I wind up slipping off the curb in front of the building, falling sideways, catching myself on the building, knocking over a display stand, and really, really hurting my arm. The gas station attendant sees it, and he's just like, "You okay, buddy?" And I'm like, "Yeah, I'm fine." And I just go to my car and I drive away because I can't be I can't be there anymore. The end result of this is, had I broken my arm doing this, that would not be evidence that the human left shoulder evolved as a blunt like weapon. That would be an accident happened. And these, I think, as Amelia would confirm, were not smart animals. And I think it's very, it's possible it just swam into the boundary of the Western Interior Seaway too fast.
The concrete edge, James, as you can see right here.
That's not the end.
It hit the invisible wall at the end of the map. Dunk.
That's not the end interpretation of that interaction. The end interpretation of that interaction is that this guy who's running possibly the world's worst gas station just thinks he let someone in to go shoot up the thickest heroin of his life, walks out, falls against the building, gets in his car, and he's like, "See ya."
I'm sorry, just the phrase, the thickest heroin.
Oh God, it was really, really not great. My arm was hurt badly enough. I had trouble using my left hand for a little while.
God.
I thought I'd broken it. Yeah, no. I was like, this is really... People are going to be like, how did you break your arm? And I'd be like, I got kind of spooked in a gas station in New Jersey. And in trying to get back to my car more quickly, I fell.
It's like a scene out of Tucker and Dale versus Evil. This guy's Letton's like, all right, yeah, do whatever you need to in the bathroom.
Yeah.
You fall and then stagger to your car holding your arm. Oh yeah,
It's pretty bad.
What he was doing.
It's pretty bad.
It's like how I chipped my front tooth the day I fired a desert eagle for the first time, but not because of the desert eagle. It was because at home over dinner I was taking a sip from my drink and I laughed too hard and slammed my face into the drink and chipped my front tooth. And I'm like, are you kidding me?
That's why you got to stay away from hard liquor.
Anyway, this is a long way of saying a general point, which is that injuries do not necessarily indicate any particular behavior. They can be the result of accidents, is what I'm getting at.
Unless there's a pattern.
Stupid.
And there is a pattern.
Oh, is there? Okay.
Mosasaurs. Well, not for blunt force trauma.
Oh, I see. Okay.
If we use this as a segue into something about these animals,
It's a good segue, yeah.
so that, and it'll also reference this design a little bit, because I've heard, justifiably, people say that its face is very ugly, which, look, it is, but I've got to tell you guys something. It's not totally out of the realm of possibility, given that these things bit the shit out of each other all the time. They're big, angry lizards. We don't know how smart they were, but my guess was not very. Even if they're smart for a lizard, that's not a high bar. Because this is a 30-foot long animal powered by a brain the size of my fist.
What's your favorite quote on lizard intelligence again, Amelia?
Dalton said this. It was that they're what you have to say something about the capacity.
Yes, lizards have, in my experience, being around lizards and thinking and studying lizards, thinking about them, I should say, they have a tremendous underappreciated capacity for intelligence. Likewise, they have an equally tremendous capacity for stupidity. There are shockingly smart lizards, and there are lizards that are so dumb I don't know how they function in the wild. Like every leopard gecko I've ever met is basically food illiterate and cannot eat correctly.
They're so dumb.
I once watched one of my pet corn snakes try to eat a mouse, and spent about 10 minutes trying to figure out which end was the head and which was the tail, because they like to swallow the head first. And she couldn't figure it out and just started swallowing it from the middle and bending it into a V shape.
I remember this.
I remember I was freaking out. I was like, is it going to rupture its own esophagus? Or something?
As we've recently learned, the evolutionary innovation of being able to accurately hit the food that's directly in front of you at least 20% of the time, which is about the best I've ever seen a lizard do it, is quite an innovation up from fish who can't eat at all.
And 99% of baby fish who starve to death because they can't eat.
Because of physics.
Fluid dynamics, baby.
Anyways, so we find a lot of mosasaurs with bite marks on them, and they're bite marks that basically had to have been caused by other mosasaurs, either because we still find the teeth lodged in the bones, or because
pretty
there's
telltale.
really,
I said that's pretty telltale. It's kind of cut
Oh
and
yeah,
dry.
it's at the Terrell Museum. They have the Mosasaurus on display has a tooth lodged in its jaw. A lot of Tylosaurs have bite marks on the frontals. Here's the other fun part. There seems to be different patterns of bite marks in different taxa, which is suggesting that they're going for different spots. So Tylosaurs are usually focused around the forehead. Oh Lord! Oh good, thank God! Yes, it's Tylosaurus. Kansasensis. Speaking of animals that were bitten on the forehead, basically the best example of mosasaur violence that we have is the holotype of Tylosaurus kansasensis. Some folks don't consider this species valid. I'll have more to say about that eventually. But regardless, it's an amazing specimen. It is at the Sternberg Museum in Hays, Kansas. It is the skull and the first couple of vertebrae. There's a couple things that stand out about this specimen. One is that it's just loaded on both sides with bite marks. And the worst one, as now Alex has seen, is like a bullet hole through the frontal. It's cool. This huge gouge. It's like about that long and deep, and it goes clean through. Now we know because we have it CT scanned. And you isolate the frontal, and it's just a hole. And what's under the frontal is the brain. So this animal was killed. It was destroyed. And in the paper talking about, I'm sorry, well, it gets better. Because, so it's got that, and it's got all these, that's the nastiest one, but it's loaded with these bite marks on both sides of the skull. And this is not a small animal. That skull's like it's like 0.6 or 0.7 meters, so it's like 2.5 feet long, give or take. Big animal, 25 foot long, give or take, as an adult. Whatever bit it had to have been bigger, which we know they got bigger. We get to talk about size in this one as well because of some special boys, one special boy in particular. But anyways, the bite marks are lined up in this perfect little V shape that looks exactly what you would expect if another Tylosaur grabbed it. And in the paper writing up this skull, not the description of the species, but the description of the bite marks on the skull, they have a diagram showing their guess of how much bigger the other animal would have been and how the angle of attack, which we could presumably put that figure up here because it's great and it makes the point. But good Lord, this thing's covered in bite marks. And not only that, it's only the first couple of vertebrae. And I forget which one it is exactly. It's either the axis or C3. Is broken, and that's not interpreted as taphonomy. Who's biting me in the arm? You little. What are you doing?
He wanted to be a part of the conversation.
I know. He's like, "Oh, we're biting." What are you doing? Fine, I'm not gonna.
Time for biting.
That's not a well-behaved. That sounds like a cat that hasn't been introduced to the shadow realm.
Yeah. I'm being attacked here. Fine.
Would you interpret this as social behavior?
No, this is bitch behavior. No, he's sitting. He's what? I've been gone for like a week. I think he was just laying on my lap. I'm petting him, minding my own business, and I feel teeth in my arm. I look over, and he's just like a shark, latched on.
It's cute aggression. He's really happy you're back.
Sure. Anyways, sorry, I got derailed by combat.
They should train cops to shoot cats. They're more dangerous.
No! Stop. Okay. Anyways.
Alex, you have 15 seconds to comply.
Oh, that wasn't even a...
No, I know. That wasn't an ob joke.
Okay. It's got bite marks on the skull, and one of the first couple of vertebrae, I forget which one exactly, is broken. The break is not interpreted as taphonomy. This thing basically had its neck snapped. And presumably otherwise separated from the body. Whether the attacker did that or scavengers did that, we don't know, but there is no reason that skull and those vertebrae should be as immaculate as they are, and there's none of the rest of it. Other than and this is kind of what we think could have happened to Yorkie. There's no reason for that thing to be almost all there and stop short, other than, obviously it could be taphonomy. We can't say that really. I'm kind of exaggerating, but it's really odd that these things are found associated with bite marks when they're otherwise well preserved. And that, again, could either have been done by the attacker, it could have been done by scavengers. We don't know. We will never know. All we know is that these animals were killed, and they did not have time to heal those wounds. Unlike another specimen that was very recently presented at this year's SVP as a poster by Ron Tykowski and my committee member, Mike Polson. This is a specimen they call the Black Knight. The Black Knight is a Tylosaurus from Texas. It is Tylosaurus proriger. It's bigger than Kansasensis. It's over a meter long. The skull would have been over a meter long. So this is a bruiser. This is in the 35 foot long category. If you've ever been to the AMNH, that specimen it's about that size. Medium for these things. Medium to large for these things.
Jesus.
Yeah, actually, I'm thinking now Texas, the Black Knight is actually a little bit bigger than the AMNH one. AMNH is 1.1 meter skull. This one was 1.2 or 3, I believe. This specimen is a relatively complete skull. It's really, really, really pretty. I'm really looking forward to this thing being published because, like, it's going to be important. But it has, like, literally the gnarliest pathologies I've ever seen on any animal. And looking at the Jurassic World thing here, like, honestly, that's like what it looked like.
It's a dead ringer for it.
Except worse. So this thing, oh my god. So this thing has like this gnarly gouge in the dentary, so in the front part of the lower jaw, that I can fit my thumb in. It almost goes all the way through the bone. It basically, it's bad.
Yeah.
And then it's got, so this is where I said there might actually be some possible evidence of some blunt force from a rostrum damage, because there's this weird lesion in the back of it that looks like an impact kind of. I can't for the life of me remember what Mike called it. That's a particular kind of injury that seems like it was like caused by an impact. And then, as if it's not bad enough, like there's 2 or 3 more like bite marks around, mostly focused on the lower jaws. The rostrum, the premaxilla, is shorn down the middle. It's missing both tooth positions. It literally looks like this. And the kicker is, all of these have signs of healing. There's this huge swollen mass behind the gouge on the lower jaw. There's some swollen edges around the impact lesion on the back. And then there's like this gnarly, horrible bone regrowth kind of happening on the snout where it's been broken. Like I said, like clean through, obliterated those tooth positions. So this thing lived for God knows how long after it had like literally half its face bitten off, which is why it's called the Black Knight after the Monty Python bit, because he just shook it off like it was nothing, except he eventually died.
All right, we're gonna have to explain that bit to our entire audience because none of them know who Monty Python is.
So the Black Knight, for those unaware, is a bit from a 60-year-old movie for children.
That's not a movie for children.
Holy Grail is definitely a movie for children. There aren't any in it. And
I thought there were.
Meaning of Life and Life of Brian does.
Cheats.
Anyway, all right, fine. Anyway. Monty Python and the Holy Grail. Hold on.
Monty Python and the Holy Grail.
Monty Python and the Holy Grail.
You might have experienced
is a 50-year-old movie.
Your dad probably put it on.
I'm sorry?
I'm just helping. I'm giving context to our viewership on how they might have experienced it. Your dad might have said, I have this movie that's so funny, I loved it a lot growing up, and then you kind of indulge him by watching it, but you're mostly on your phone.
Right.
It's a good movie. I like it.
It's a funny movie.
Yeah.
It's a movie that exists, and there's a scene in it where a character called the Black Knight has every single one of his limbs cut off with a sword one by one.
Bitten off. No,
right.
Yeah.
I'm thinking about these.
Yeah, it's like he's guarding the trail or whatever, so they have to fight with him.
Right.
But they don't want to fight with him, but they do anyway. And it's every time another injury happens, he just keeps going. It's just a flesh wound.
Right.
Oh, I'll bite your leg, whatever. It's always like a stomp.
It's a funny movie.
Yeah.
It's a funny movie. You know how they say there's nothing that ruins a joke like explaining it? We've just explained the joke to you because we realized that our audience is probably young enough that this movie might not be on some of your radar. And if it's not, you should watch it. It's kind of a cult classic. It's not, it's not the best Monty Python movie, but I think it is the most accessible to people who don't already know what Monty Python's deal is.
Yeah, sure.
I think there's a reason it's everybody's first, which is good.
Yeah.
There needs to be one that's a gateway.
Well, it's like the quote from E.B. White. Explaining a joke is like dissecting a frog. You understand it better, but then the frog dies.
Well, I just basically what it sounds like Amelia has described is that there was a mosasaur, a 50-foot long missile traveling at I don't know,
the speed of sound.
We'll say 40 miles per hour, hits it in the face. And you're like, oh, well, that animal's died. And then it gets back up, spits out a few teeth, and it's like, that all you got?
And then it has
kind of incredible.
Now ripped off. It's so horrible. Like, it's the worst. I first saw it last spring in February when I first went to Dallas, and I was like, I was overwhelmed. I'm happy I can mention it at all, because it was presented, and Ron shared a picture of his poster on his Twitter. If you are inclined to look for it, I won't share it here because it's his thing, but I can't wait for them to get it out because it's wild.
I think
Is there any evidence that this might be like a mosasaur that everybody hated? Like, was this just like
was it just
the one Tylosaur, and everybody else was like, we got to do something about this guy?
he's the
I mean, who knows?
Right.
I mean, they were just. These are not kind animals.
They took him to a meeting in a room with just a taxidermied swordfish on the wall.
I was going to say they all put soap in some socks.
Ow. Ouch. Ouch. Great scene. Don't do that though to someone. It's very bad to do that.
Yeah.
Anything in Full Metal Jacket, just put the stamp of this
Don't
is
do
bad
that.
to do to another person.
There are one thing I've been trying to Google this for a while to look for pictures, and they are available. We'll try to put some up. Because Amelia describing this mosasaur made me think of some crocs I've seen with like similarly grievous facial
Oh my
pathology.
god.
Just missing
Yeah.
the front.
Right. Well, one's missing its entire lower jaw, which I feel like is almost worse. Like, it's just the skin's like folded in around it. Like, I don't know how it stays alive. I wonder if maybe they just heal before they starve to death because they're ectotherms. But
There's some sperm whales like that too.
Oh
It's
yeah,
crazy.
I've seen like not skulls, the jaws, the bones, where they're like.
yeah,
Well, there's a couple that I've seen pictures of that are just gone. It's like, what?
right.
How?
Yeah, and that's so. I think part of what this paper. I'm not on the paper, but I imagine part of it is going to be figuring out what's going on internally with the bone structure to kind of get an idea of how long was this thing healing for before it died. What other signs of it? Are there signs of infection? Which, like, undoubtedly, probably, it's so gross and gnarly. But like, yeah, so keep your eyes open for this to be published soon by some very, very, very nice people, very good researchers that I work with frequently. But anyway, the
Nature
point
and
of all
science.
this.
Why did everyone hate him?
Yeah.
Who were his
He's-
foes?
Everybody, the world. They hated everybody.
Shabiri.
Which is another good segue for they ate everything. We've got evidence of that. Both in, like, literally everything and anything that lived alongside mosasaurs has been found with bite marks from mosasaurs. Which are pretty distinct, among... So I kind of touched on it earlier. They're distinct among aquatic bite marks because, like, these things basically have railroad spikes for teeth. That's not really like anything else. Like, at this point, there aren't very many pliosaurs, if any, left. So there's, like, nothing else alive at this time that could leave a mark like that. Sharks leave, like, in scavenging marks, the sharks will leave, like, little shallow scratches, which Kansas census also does have, actually, really nicely on one side of the jaws. Or they will shear things clean through. So there's a couple mosasaurs like that are just, like, cut clean through. Plesiosaurs don't seem to be leaving bite marks unless I'm mistaken. I don't know what they're doing, but it makes sense if you have goofy needle teeth. Like, I don't know, you're not going to be puncturing bone with those, I guess. Yeah. There's that's it, nothing else. Like, these things are ruling the oceans at this time. And the
Question about their teeth. So they have kind of like a weird thecodont dentition, right? Like they're in their own separate holes. Are they the only lizards that do that, or do snakes do that, or are they also doing something else?
Snakes and some other lizards do it's not as thecodont as mosasaurs are. Okay. And Dalton, you can correct me, but it's like snakes, and I thought like maybe some teiids, like where it's like they're starting to
I don't
pseudo-thecodonty, but it's nothing like.
Yeah, it's not really comparable to mosasaurs. I don't know about the teiids. You could definitely be right, and I just don't know about that at all.
I just knew it was more than snakes. I thought there was one other.
Yeah, snakes have weird teeth and weird tooth implantation, and just a lot of things about snake teeth are weird. But they sit on top of the jaw like mosasaurs. Okay. They're not quite as pleurodont as most lizards. And I think there might be some snakes that have kind of little depressions. I could be wrong. I don't spend much time in the world of snakes because while I love them as animals, I just, for whatever reason, don't find them as interesting to research. just to be clear, like I'm not an anti-snake person, but I am not interested in snake science or doing snake science, I should say.
Okay.
Yeah, and so the difference here is, so to explain to the viewer, usually lizards, like we think about teeth in sockets because we have sockets and dinosaurs have teeth in sockets.
All archosaurs.
Right? All archosaurs. Okay, yeah, sure. But lizards don't do that. So usually in lizards, what's happening, if I can use my visual aid here, is that the tooth will be growing kind of like up alongside the jaw. So this is from the inside of the Komodo dragon jaw. Like they're either coming up from the side or they're either like stuck on the side of the bone or they're stuck on top of the bone, but they're not actually in a hole or in a socket in the bone. And basically what mosasaurs have done is they've taken the inner wall of their jaw bones and grown it up and around their teeth. So if you actually are holding a piece of like a mosasaur jaw, it'll look like it has holes in it. It looks like it has sockets in it because they do. So it'll look like a croc jaw or a dinosaur jaw or a whale jaw. So, for example, the first fossil of a mosasaur, Mosasaurus, there was a lot of debate about what the stupid thing was because it looked a bit like a lizard, but also it had teeth and sockets. So there was talk about, well, maybe it's a weird crocodile or a whale, because lizards don't have teeth and sockets, but mosasaurs do, which is super cool. I don't know why. I don't know much about teeth. They scare me. They're very complicated. They're cool, and I'm glad there are people who care about them. But I wonder if it doesn't have to do with, I don't know, something with how they're biting that's different.
Could be.
Or even just scale. Like, they're just so big.
I mean, that's a pretty profound developmental difference. Like, I feel like I was amazed when you told me that they were like thecodont, or like, I've heard the phrase pseudothecodont. I don't know if that's something we actually use and refer to the reference.
Well, mosasaurs are thecodont. I think it's snakes are called like subthecodont or pseudothecodont,
Well,
but I think mosasaurs, as far as I know, are considered thecodont.
But I was just amazed that wasn't a difference that like wasn't talked about more. Like that is such an amazingly profound like, I mean, the different styles of tooth implantation, right? So Amelia described two of them that I think, do lizards show both acrodont and pleurodont dentition? Yeah. So in acrodonty, they're mounted just on the top of the jaw. Pleurodonty is when the root of the tooth is oppressed to the side of the jaw, but there's no socket. Developing the tooth in a socket is like a really big developmental thing. Again, that is like a synapomorphy of archosaurs. That is a synapomorphy of mammals.
And it's very rarely even lost.
Right. I mean,
unless you have
is it really ever truly? Right. That's a huge thing. Like, I don't know. Like, I guess my initial instinct was just like, is it that the tooth-bearing elements are walling around the teeth, so it looks like it's thecodont, but they're not like developing in a true developmental alveolus. But it seems to be that they are, right? Yeah, right.
Yep.
So
that's how it started. Is that the wall grew up and around, and then like in some species, the separation between the teeth is more pronounced than in others. But they are like, it's one hole, one tooth, and that's part of the reason like these guys. So like I joked before this that the only way we could actually tell what species this is if we counted the teeth, but even then we kind of can't, because mosasaurs, at least the big derived ones, tend to like lock in on tooth count. Like every genus tends to have the same number of teeth, like in all the jaw bones. So you've got, well, all mosasaurs mostly. There's a couple early weirdos have 4 teeth in the premax, and then you'll have the same number in the maxilla for a given genus, the same number in the dentary, and the same number in the pterygoids. Sometimes there's like a plus or minus 1. But at least in Tylosaurs, which are the ones that, like I've said, I've seen the most of these specimens myself. I've counted all of their teeth, and in the sample size that I have, I think it's a pretty reliable pattern. The number for them is 13. So 13 in the maxilla, 13 in the dentary, 10 in the pterygoid. The older species, Nepealicus and Kansasensis, tend to lean towards 14 instead of 13, but not always. It's kind of a mess. And then the bigger ones tend to lean towards 13 or 12. So like when there's a discrepancy from 13, the later ones tend to go 12, the earlier ones tend to go 14. And in the pterygoids, it's the opposite. It's actually the same. So the later ones all have 10. Like the pterygoids seem to really lock in. And the younger ones are not younger. I keep saying younger. The earlier ones I believe Kansas census has, and those like the other early Kansas ones have 11. When I say Kansas census, to be clear, I mean the holotype, because we have the scan of it, and that's just what I call that specimen, because it's quicker than its number.
And
But yeah.
For our viewers who are less well versed in lizard skull anatomy than we are, the pterygoid teeth are the ones on the roof of the mouth that you can see on the very famously and very prominently on the Jurassic World mosasaur when it eats the shark or the assistant.
Yes.
Right.
You can kind of
Also,
see
I
him in
think-
this guy. It's a little dark, but
I think Chevoia is like one of the only pleurodont archosaurs.
ew, what?
Yeah.
I think all its little teeth
Ooh,
are.
I don't like that.
Yeah, I would.
Yeah.
Might I interject here for a brief moment, just a
Please.
note on tooth implantation? Because I was looking up a paper that I knew existed. Because if you're interested in this stuff, check out the work of Aaron LeBlanc. He does a lot of really good work on teeth. And he has some work on mosasaur tooth implantation and the way that and it's also important to know that people have talked about like the way that we talk about teeth in terms of their placement, their mode of replacement. And we kind of talk about them in like topologically, where are they? How do they attach physiologically? And oh no, I lost the plot. More or less those two. It's kind of like where they are and how are they attached. And mosasaurs are topologically thecodont, and some snakes, it looks like, are approaching that condition as well, in that the tooth rests in a socket. And it seems, though, that the way that the teeth attach into that socket, it's all by calcifying the periodontal ligament, but it's done differently in mosasaurs compared to, like, in archosaurs. And so they've approached this in a different way in terms of, like, the timing of when things calcify and stuff like that, in a very broad stroke.
Yeah, when I was talking about how scary tooth research is, I was thinking of Aaron specifically because he's done that's his thing. He's really good at it. It's if you want to learn about teeth, especially in like squamates, like he's the guy to go to.
So you may have noticed that in this discussion of teeth and tooth implantation, we've referenced other groups of squamates a lot. And so what I think is like, what I personally find the most interesting about mosasaurs, which are like, I think there's like two huge questions that can be asked about mosasaurs. Like one is water to land or land to water transition stuff, right? Like this is one of these many groups of vertebrates that's returning to the water. That is a host of interesting questions. As a systematist, one of my other questions is what the hell are these? And the answer is that it's harder to decide than you think.
Yes.
So systematics,
They're lizards. I've solved
Mosasaur, okay, they are lizards. Thank you, Alex.
Yeah.
Right. The based, take it back to the most inclusive clade you want and say it's that, and decree that the question is answered approach. So they are lizards, and that has, I don't think, ever been in dispute, right? Like they're
Except like initially.
well, right,
when they didn't know it, yeah.
but like since we figured out
It's
that
a
they're lizards,
crocodile lamb.
nobody's really questioned it, right? The thing is that there has been this historical debate over what kind of lizard these are. And I think this gets into stuff that like Dalton and Amelia have thought a lot more about, and I will turn the floor over to them in a moment. But the core of the debate is, are these more closely related to monitor lizards like Komodo dragons
Yes.
or to snakes? Thank you, Alex. That has flipped back and forth. My understanding, and correct me if I'm wrong, is that the initial interpretation was that these were like some sort of sister taxon to monitor lizards. The famed comparative anatomist Georges Cuvier, who like basically came up with comparative anatomy as a field and the concept of extinction, curiously enough, did not believe in evolution. We touched on this
So
in a
weird.
prior video. Well, right. His idea was that all parts of an organism correlate to one another for their function, and therefore evolution can't happen because if you change one, then it's not correlated to the ecological role of the organism, and it would go extinct. So
that takes so many more logical hoops to jump through to get to that position.
well,
But
I
sure.
mean, right. I mean, listen, it's wrong, but it's an interesting way to... It's not that he didn't believe in
Yes.
evolution because he didn't think of it. He said, this does not map with how I think the world works, and so he dismissed it.
Yes.
But this is getting lost. His initial interpretation of mosasaur fossils were that they were large lizards, large marine lizards that were closely related to monitor lizards. right? So like big seagoing Komodo dragons. It's then Edward Drinker Cope who proposed, based on his study of the animals, that they were actually the closest relatives of snakes. And he united them with snakes in a group called Pythonomorpha. And to my knowledge, that has basically been where the field has flip-flopped between over time, with the exception of, like, is Jacques' matrix the only one in the 2012 analysis that got them elsewhere than those two hypotheses?
It's the only one I know of.
I think so. I feel like there is another one, but I don't remember. I think there's a Conrad one that's slightly different.
I was about to say, Conrad found them in a polytomy with monitor lizards and beaded lizards. So he's still...
It's still anguomorph.
He got them as anguomorphs, and certainly as, like, I guess as, like, what would that clade be, like Platinotans?
Yeah.
It'd be beaded, right. Yeah. But, like, with an unclear relationship to other members of the clade. I'm going to turn the floor over in a moment, but I think that this is a wonderful encapsulation of the fact that systematics is an active area of research. Like, I think there's a tendency among people in our field and outside of our field especially to look at, like, the most recent tree is just the correct or must be the most up-to-date answer. And this is an area of research where answers change constantly because you're constantly adding data and you're doing different versions of analyses that will give you different answers. Like, different ways of running the same tree can give you, or the same matrix can give you different topologies. So I think it's just something important to keep in mind that there is no locked in 100% official, this is the tree. There are only the current version as we know it from the taxa that we know about and the anatomy that we know about, and our methods for inferring phylogenetic interrelatedness. And so I think it's just, it's a good encapsulation of systematics as the active field of research that it is, not us drawing the tree we like and deciding that's what it is.
Yeah.
And certainly there's never the answer that we solidify on is through consensus of different analyses, not because it's the most recent.
Congruence,
as they say, right?
Yes.
Yeah. And for mosasaurs, like, adding to this point that it's an active area of research is, like, there was just two new papers last year that came out with a new hypothesis. It's the Varanoid hypothesis, but it was the first, like, reanalysis of their position in a couple of years. So it bounces between these two hypotheses depending on the data sets that you use and the people who are working on them and the fossils that they use. And I think this is also a really good example of the problem with homoplasy and convergent evolution in fossil animals, especially because mosasaurs are lizards, and lizards like to go wild. With convergent evolution, it makes it hard. Like, the reason that we keep getting different answers is that because mosasaurs are specialized in the way that they are, it's really easy to see how they could be seen as snake relatives or monitor relatives. On the one hand, if you look at their skulls, like, just at a glance, like, overall shapes of all the bones and how the skull is constructed looks very much like a monitor lizard. But then in a lot of the nitty-gritty details, there's some things that tie them to snakes. Like, these hypotheses aren't coming out of nowhere. The trouble is we don't know which of these similarities are due to shared ancestry versus homoplasy. And that's something that, like, without the DNA, without their genetics, it's basically impossible to know until we really flesh out the fossil record. If we can get more early specimens that better show the transition of what these things look like on land before they got into the water, because basically a lot of the reason they look the way they do is because they're aquatic. That's why their faces are all long and drawn out and look like a varanid. They're macropredators. That's why they've got all of their tooth adaptations that look like varanids and everything like that. But yeah, no, it's wild. It's fun.
Yeah. And another group that, I mean, not to relate this to a different group that you may know about, but, like, paravian dinosaurs, like these theropods that are closely related to birds, are another example of one where there's, like, a huge amount of homoplasy. There's a huge amount of convergence going on. They appear to be evolving flight itself multiple times. That makes systematics difficult.
Yeah. Quickly to define homoplasy, because we've said it a couple times, and that is kind of an advanced word, and we're just kind of throwing it around. I know we don't like to necessarily spend time on jargon here, but this one I think deserves it. So homoplasy is when two features, or like when features on different animals look the same because they have a similar function, and not necessarily because they're coming from shared ancestry.
I don't think the function aspect is even mandated. It's just
It's
that
not,
they're not.
That's usually what's happening.
No, I mean,
right?
Often,
Like,
yeah.
It doesn't have to be that they have a shared function. It could just be random. But generally, what's happening is that, like, think of bird wings and bat wings and pterosaur wings. They didn't inherit wings from the same place, but they all have wings.
So, forgive me if I am not beating the not a real scientist allegations.
No, Scott.
Why don't we just use the regular word convergence that we already use for the same
So
thing?
homoplasia is defined in opposition to homology.
Yeah, no, this is like the thing, and convergence is like the process.
Yeah, I mean these are I mean if we're being the most, I don't want to say pedantic, but like just the most granular about like what it means, like a homoplastic character is dependent only on its distribution across the tree.
Yeah.
Right.
Versus
It is when
else.
it's the same character state, but
Yes,
it's not
exactly.
optimized as shared derived.
Yeah.
Right.
Yeah, that's I was just thinking,
which-
like, the even more simple way to put it is that a trait that is the same, but not necessarily because it's coming from the
It's
same
not
place.
shared.
Not only not necessarily, literally, it
like, okay,
has
fine,
to not
it's
be.
not-
Right, yeah.
It's
Right.
not shared
Yeah.
in a derived sense, and it's not shared in a privative sense. It is originating as best as reconstructed at least more than once.
Speaking of things that originated more than once, we can move up into the second level of phylogenum hell, which is the intra-species relationships of mosasaurs a little bit. Because I think they're a lot more complicated than people give them credit for. Like the reason that Tylosaurus and Mosasaurus will not be the same videos, because they are very different animals when you strip the skin off and actually look at the anatomy. So within Mosasaurus, thank you. Within Mosasaurus proper, everyone has their own definitions of what is a mosasaur. In my opinion, they include the Agialosaurs and everything above. So Agialosaurs are the little leggy guys that still basically look like, regardless of what they're related to, they basically look like little monitor lizards, except they're kind of long, and they were swimmy. And everybody up. And what's fun is that it seems like it's not that simple. So we used to think that, okay, there was an Agialosaur, and then there was some kind of basal mosasaur that had so the Agialosaurs have legs, and they're still really small, and their faces are really short and kind of lizardy. And then there was this early mosasaur that had flippers and kind of had started to get a longer face. And then after that, they diversified into the 3 or 4 major groups. There are the Tylosaurs, the Mosasaurines, the Tylosaurines, the Mosasaurines, and the Pliopodicarpines. Depending on who you ask / what you believe, halosaurines are kind of also their own thing, maybe. We don't really know. Everybody's analysis gets them somewhere else. Yay, whatever. We thought that there was this ancestral mosasaur. This ancestral mosasaur split into the mosasaurines and then everybody else. Everybody else being the russellosaurs, Tylosaurs and Pliopodicarpines. And that. But we thought that they were getting the initial mosasaur bowplon from one place, from one ancestor. There was one ancestral mosasaur that then split into the different kinds. It doesn't seem like this actually happened. It seems like these things evolved flippers and large body size and a bunch of other adaptations for living in the water independently, as many as 2 or 3 or Jesus 4 times. Depending on how you read the tree. Like, this is why, in this group especially, like, taxonomy is super important, and understanding of the early guys are really important because it's important how those characters, we were talking about character distribution on trees. So the presence of flippers, where does that show up in this tree? It's really, really important to have these guys sorted out right. And one of the key specimens that started to kind of throw all of this out of whack was Tylosaurus. So that's a mosasaurine. So that's Mosasaurus, Clydastes, Yorgi, Prognathodon globidens, and some other friends. Tylosaurus is a basal mosasaurine. So it's already separated from Tylosaurus and Pliopodicarpines. But it's got, like, leggy bones. Like, it doesn't quite have flippers yet. Wild. We know, but it already is a mosasaurine. Yes, Alex?
Just so I'm not confused.
Yeah.
So is the proposal that there have been multiple, like, Agialosaurs are probably mostly marine, right?
Yeah, they're aquatic.
Okay.
I don't know if they count as marine because they're not like.
It's not that multiple lineages of
Do they eat
weird
crayons?
lizard have
Sorry, go
reinvaded
on.
the water. It's that there's one
it's
wet
that-
lizard
yes.
stock that you're making many
Yes.
big wet lizards from.
Yes, exactly.
That's
So there
funky.
was
Okay, cool.
So my understanding, and I think the current understanding in general of what happened, is there was one invasion of water by the Mosasauroid ancestor, and that's going to be the Agialosaurs and all these other goofy things. And this gets complicated because there's not a lot of the early stuff. There's Agialosaurus, Opetiosaurus, which some people also think is also just Agialosaurus, Paleontologists, and the Dolichosaurs, which are also very weird in their own way.
So when is this all
But
happening?
they seem. This is all happening in the Turonian. So about the Turonian, and I think it's technically happening a little bit before. The number that I'm really bad with the dates.
But like just
100
like
million
early
years.
Cretaceous, middle Cretaceous.
Yes.
Okay.
Well, middle. Yeah.
This is,
About 100 million years ago. There's this smear of wet lizards. So, like, I'm not saying that mosasaurs are paraphyletic. That's not what we're saying. Like, we agree. Stop. We agree.
No, I just don't like the wet lizard smear.
I don't either. But look, I'm trying to not get into hyperspace with my terminology.
when you go into a Santonian bagel shop, do you want the
wet lizards?
smear?
Okay, so like basically there are the early mosasauroids. We think that those are all related, but we don't know how exactly, and those different guys are giving rise to the different mosasaurs proper. We know for sure that I'm gonna kind of ignore the halosaurs. If you're a halosaur fan, don't be offended. We need to do more work on them. They're insane. They're so weird. They're really cool, but they're really, really understudied because there's just fewer of them in collections. So we're gonna set them aside because they have been put like in every place on the tree. It changes every time. It's wild. So of the main three, the Plioplatycarpians, Tylosaurians, Mosasaurians, each lineage independently evolves, we think, flippers, large body size, reduced tooth count. Something I'm forgetting. I knew there was another one.
Is the tooth implantation thought to evolve multiple times?
I don't think so. I think the answer is in one of the Agialosaur papers. I would look at the Opetiosaurus paper because that one has the best. I was looking at that picture earlier of that specimen, and the specimens are rough. So I would trust a description by someone who was sitting in front of it over my pictures. I don't believe the tooth implantation evolved more than once because that's pretty conserved. The differences between the different groups are one of the differences is how high that medial or inner wall is relative to the base of the tooth. So in some of them, it actually sits quite far below it, but it's like still there. In others, it's like all the way up and around, like in Tylosaurus and Mosasaurus. So it's possible that it started in the Agialosaurs, then each group kind of continued it on its own. That would be wild, but like they're already converging on everything else, so why not add another one to the pile? But flippers, body size, and reduction of tooth count, all three groups do independently, which is wild. And those things tend to happen, in concert with each other. Within the Tylosaurines, so what makes them different relative to the other two, just in general, they tend to have less well-ossified flippers. So like more of their wrist and ankle bones are just cartilage, compared to the other two groups. So like if you look at the specimen on display at the AMNH, it has like a single wrist bone and a single ankle bone. The others were there; they were just cartilage. And they tend to ossify. There's something else that's less ossified in them. But anyway, they're really their pelvis is also like loose. Like all three bones are just kind of hanging out, attached by soft tissue, but they're not actually like sutured together. Versus like mosasaurines do. So it does seem, at the very least, mosasaurians and Plioplatycarpians are more closely related to each other. Jury's still out. That's why I say independent origin of flippers is either 2 or 3, because we don't quite know what's going on there yet. We don't have the right fossil to know that yet. I take that back, actually. It's Tethy. Tethysaurus is an early Paleoplatycarpian, and that was also published very recently by my committee member, Mike Polson. Tethysaurus is a early Paleoplatycarpian that presumably had legs, still more so than flippers, and it has the unique neurovasculature arrangement in its brain case that is like that Paleoplatycarpians have. Like no other mosasaur has it, and Tethy already has that arrangement. Super cool, super good reason for including CT data in solving these questions, because that's something we would never know if we hadn't scanned those. Anyways, so Tylosaurs have like no bones in their wrists. They have the really long pointy faces, which we already talked about. Proportionally, their heads are proportionally smaller relative to their body, and their tails are proportionally longer. And this one actually gets the flippers wrong, as I found out with a friend of mine, the Kirsten Formoso, friend of the channel. We saw this on the AMNH specimen, actually. The rear flippers should be a little bit bigger than the fore flippers. And this is length of the digits, not length of the bones. Because when she told me that, I was like, no, they're not. They're the same. But I was thinking of the humerus and femur measurements I had taken. Those bones are almost always the same length in mosasaurs, which is interesting. Like, I don't know why. So it's actually just the fingers, the toes themselves. On the hind flippers are longer.
Speaking to that, can I ask you, Amelia? Because it's always struck me that the fore flippers of this model look like extremely big, which it makes me think of that new mosasaur that just came out with the big hands.
Yeah,
that guy.
When you mentioned that the fore flipper should be smaller than the hind flipper, if you were to adjust this model kind of based off of the proportions of the body, would you enlarge the hind flipper or would you shrink the fore flipper to be smaller?
A little bit of both.
Okay, fair.
I feel like, a little bit of both, because it's like, I feel like if you swapped them, it would be too small, at least. Like the fore flippers would be too small.
Okay.
Sorry.
It's good enough.
I think we're dropping like flies
we're
out here.
Talking about flippers, and everybody's
We're all
running
distracted by
away.
the fact that Alex and James have both had to go off to do legitimate things that they had to leave briefly for. But it's like the scene in Jurassic Park when everyone walks out of the moving car, and now here we are by ourselves talking to ourselves.
Yeah.
Mm-hmm.
No, but anyway, that's a good question. Yeah, I would.
Scott.
Yeah. Well, you've handled the genotype, so you're up there.
Isn't it the holotype? What's the difference?
It's the holotype of Tylosaurus.
Oh, okay.
Yeah.
Okay.
That's why I sometimes call it genotype. I don't know if it's actually real or not.
All right.
The generic type. Because that just sounds too mean. But anyways,
okay. I guess question wouldn't like it has a species.
Yes.
Yeah. It is both the species and genus type.
Then isn't by definition every type like holotype a genus and species type?
No.
Because
like Tylosaurus kansascensis is not the genus type.
Okay. Yeah. All right. Sorry.
Yes, if there are multiple...
I was thinking dinosaurs for a second and forgot that things can have multiple species.
No, incredible things happen when you have a good sample size in animals. You can actually have multiple individuals of the same species and multiple species of a genus. It's really cool.
Yeah.
We can talk shit about dinosaur taxonomy. They're not here.
Oh, yeah. Mm-hmm.
Not really. It's just like it is interesting that, at least to me, with mosasaurs, there's been a lot of parallels in like taxonomy questions that we see in dinosaur research all the time. I won't talk about that shall not be named, but I will talk about Torosaurus, for example. Like, so Triceratops and Torosaurus, it was proposed that Torosaurus is an adult of Triceratops. For Tylosaurus, there have been a couple things. A lot of things have been published really recently about Tylosaurus taxonomy and systematics. One of them was that Tylosaurus kansascensis is actually the juvenile form of Tylosaurus nepilicus, and another is that Hanosaurus is just Tylosaurus. So I have feelings about those things that I won't get into here because it's a lot of like what I'm working on currently at the museum for my PhD. So like, fear not, you'll hear about it soon enough. But it's interesting because we can approach these questions in a very different way, I feel like, than a lot of areas of paleo can. Just given A, the sheer sample size that we have of these things, and B, the understanding of modern lizards that we can use to actually inform these decisions. Oh, right. So to kind of circle all the way back. So Tylosaurs, I talked about what they are. There are a couple different genera within Tylosaurines. There's Tylosaurus itself. There is, depending on who you ask, Hanosaurus. Tanyosaurus is Antarctic. At least there's Antarctic and New Zealand, like Southern Hemisphere critter. And there's a crappy thing called Kaikaifalu that was shown in Prehistoric Planet. It's like a smear on a block of nothing. It is so hard to interpret. I understand why they put it in the show, but I wish they just did Tanny, because it's like, if it's a Tylosaur, it's probably Tanosaurus anyway. But anyway, Kaikaifalu was originally interpreted as a Tylosaurine. Someone in a paper said that it was probably not a Tylosaurine, and I looked at granted, I'm looking at the photos, but it's like, I don't think there's enough of it there that's discernible to know at all what it is. So anyway, that one, some people count it, some don't. We need another one, basically. Which is unfortunate, because it's a really cool name. It's named for like a sea monster from a local.
It's such a good name.
Yeah, and Tanny too. Tanyosaurus is named for another like a sea deity, I believe.
There seems to be a pattern of naming mosasaurs after aquatic deities or something like that.
They
Amelia,
are.
would you know anything about this?
I sure would, but it's a mosasaurine, so I'll talk about it for mosasaurs. But like, this actually segues into another point about Tylosaurus, is that all mosasaurs are big, right? Like the biggest lizards we have today, if you don't count snakes, which like snakes are lizards. Do not pick a fight with me about this. People have tried in the past. It's the dumbest argument I've ever been in my life. Snakes are lizards. But whatever. It's one of the. I think that the actual dumbest argument is that birds are not reptiles.
It's, you know what?
That.
I haven't had to do my quarterly relitigation of that on the internet in the last quarter, so things are actually looking up, I think, because I swear 4 times a year.
Dalton, that's because they're all busy with me on Wikipedia trying to roll back dinosaurs being birds.
Oh, right.
Or birds being dinosaurs, rather. Yeah.
Okay, so anyways.
Which, like, the only Wikipedia editorial dispute that's ever gotten news coverage.
Okay, so snakes are lizards. If we count snakes as lizards, the biggest lizards alive today are like the pythons that get to be like 30 feet long. But if we don't count snakes, the biggest lizards that we have today are Komodo dragons. And I think the biggest ones get to be like 9-10 feet long. That's very small in mosasaur world. Aegyalosaurs are already like 4, 5, 6 feet long. Dallosaurus is like, I think also in the neighborhood of 5 or 6.
I thought for some reason it was like this big.
No, it might be smaller. I'm not entirely sure. It's so incomplete, and it's one.
I mean, I trust you. So that was just my vibes-based sizing.
Under 10 feet. It's not teeny tiny. It's under 10 feet, but it's not pocket-sized.
So it's either like the size of the largest lizards alive today, or bigger than the largest lizards alive today.
Right.
I mean, like,
it's insane, and that's the Cladastes we have at the AMNH. So, Cladastes 192 is out on display. You might not have seen it because it's kind of off in a corner. You'll see the big one. That's 221. That's a big Tylosaur. But that Cladastes is like teeny tiny for a Cladastes. It's only about 9-10 feet long. That's not very big at all. That's baby, but it's the size of a Komodo dragon today. I think it might actually be a slightly bigger. I'm thinking of, I have its skull in my office, and it's slightly bigger than the Komodo skull replica I have sitting here. Like,
so I guess even though they not technically, they're incredibly much not lizards. Like, these guys are, like, I guess a closer size estimate to even the smaller ones would be the biggest crocodilians.
Yeah, and that's kind of earlier today when I was talking about the AMNH one. I call that one medium sized. Like, that's like medium. It's in the medium range, because small for Tylosaurus.
Up, honestly,
the smallest Tylosaurus that I'm aware of that's definitively Tylosaurus would have been Oh, it's that one. Oh, it's that. It's a cute little boy. Oh my god, it's so cute. It would have probably been in like the 12-foot neighborhood, somewhere
Jesus
in that range.
Christ.
Teeny little baby man. He's in a little Sternberg plaque mount in the collections of VP78. You can find him on the Sternberg database if you want to look at him. But anyways, teeny tiny, 12 feet long. The one at the AMH, and then there's a couple others that are like in this range of I think a lot in skull size because that's the numbers that I usually use for calculating estimates and stuff because we don't usually have the whole specimen, but we often have the whole skull. So the skull size of little baby man is like, I don't know, 0.3-ish meters, so it's like a foot long. The next kind of size category, the small normal size, is like skulls about a half meter long, give or take. So these are like 20-foot long animals. Medium is meter-long skulls, 30-foot long. That's about the one at the AMH. There's a gaggle of some from Texas, like the Black Knight, that are in this kind of 35-ish foot zone with skulls that are 1.2, 1.3 meters long. I apologize very much for flipping between metric and imperial measurements here, but I don't have time to do math on camera. Try to keep up. Anyways, then we've got the big man, the bruiser, the boy, Bunker. Bunker is awesome. Bunker's skull is as long as I am tall. The whole animal is about 46 feet long, give or take. It's so cool. It's so big. It's ridiculous. The first time I went to, so this is a specimen at Kansas University. I wish I had time to read up a bit more on the history of it because it was really interesting, like the circumstances of its collection. It was collected not by paleontologists, I don't believe. It was collected in 1911 by like, it's something to do with like a military or militia group. I don't know. It was not a group of paleontologists that collected this thing, which, like, considering that, I'm glad that they did a pretty good job, all things considered. The surface texture of the bones are kind of crappy, but, you know, what are you going to do? So the specimen is at Kansas University. It is their logo, so I'm wearing that shirt today, which is not really visible because the way I lean, because I can't sit in a chair normal. But it's their logo, and it is there when you walk into that museum on campus. It is hanging directly above. It's 50 feet of lizards spiraling above you. It is so cool.
Having just seen it recently, it is incredibly cool. It's just much bigger in person than I imagined, even from just hearing the size. It's cool. It's a really cool animal.
It's so cool. And it's like the way, like, you actually, like, there's a chance you might have seen it in a traveling exhibit or something, because, like, it has been casted by Treebold, and they, you know, distribute the cast traveling exhibits. And if you happen to have, like, several $1,000s that you want to spend on a thing, you could just buy one if you wanted. I've threatened my boyfriend with that. Like, if I ever hit the lottery, we are mounting a bunker skull in the living room.
Amelia, your apartment is not large enough for that animal.
Not in the apartment. Well, not in the apartment, no.
Okay.
I imagine if she hits the lottery, she's also getting a bigger
Everything. That's the compromise. It's like you can buy your Tylosaurus, but we're staying.
Okay. So, anyways, the way I describe, like, people ask, like, if you ever find yourself thinking, oh, is that one Bunker? It's like, just think, is this bigger than any animal has any right to be? Like, if that's how you feel when you see it, that's Bunker. And the funny thing about Bunker is the first time one of the funny things about Bunker, the first time I went to KU, they didn't know where it was, which is great.
How do you lose a 50-foot lizard?
Right. I think the collections manager had just started at that time and no one had asked for it before. And they were in the process of, like, re-cataloging everything. I remember her, this is Megan Sims is her name. I think she's still there. I remember her showing me, like, this really huge old book with, like, all of the different specimen numbers through the because everybody, of course, they all have different specimen numbers, and it's just a disaster. It's great. So I got there, I was like, okay, and I had no idea what this thing looks like, because the only published, it's not even published, the only photograph of one of its real bones that exists online is there's a picture of its quadrate, the ear bone, on Mike Everhart's Oceans of Kansas website. So that's all I know that exists of this thing. No one's ever published on it, other than to say, hey, it's pretty big. So I didn't know what I was looking for. I didn't know what kind of state it was in. So as I was working, I was just like, they had two skulls that were bigger than I'd seen before. There was 1032, which is on display. It's 1.2 meters long, which at the time, bigger than I had seen prior. And there's one in the basement that's like a horrible gray smear. And that one's like 1.3, 1.4 meters long. And I was like, okay, those are pretty big. Maybe that's it. And then later it was in the other collection space, not the basement, where I saw the quadrate out on a shelf. And I was like, oh. And she's like, oh, she told me where the postcrania was. We knew where that was. Okay, we have that. She didn't know where the skull is. I'm like, okay. But I found the quadrate, and then I looked below the quadrate on the shelf, and there was a skull, like I said, as long as I am tall. It's like, that's it. That's the creature. Oh, it's so good. So we brought it out on, like, it was me, Megan, and her, she had an assistant, like a student assistant. It's on, like, a sled so that it can be brought out from off of the shelf. And you need like 2 or 3 people to pick it up and to move it, and it's insane. It's so cool. It's got one of the hyoids too, which I didn't know, like just in one of the drawers. Yeah, it's a really cool specimen. It's got most of its limbs. It's not in great shape, but it does tell us something, and it tells us that these animals got huge, which is really cool. And like it's approaching the zone of the original Jurassic World Mosasaurus. Which I believe is like, 60, 70 feet long?
I think it's advertised as like
Something
70,
like
and I think if you scale it to the shark, it's like 90, and then in the sequels, it becomes kaiju size because they don't know what to do with it.
So if we trust the propaganda that it's 70 feet long, like, that's not too far from Bunker and from, well, there's a Mosasaurus specimen that I can mention at another time. That's also, like, it's in that category. It's in that realm of, like, to circle back, there's a reason I think that these things deserve to be named for deities. Like, they were absolutely ruling all of the wet environments, save for the ones they couldn't fit in.
So, to piggyback off of that for a second, I was curious when I was initially going to see if there was any possibility that we could say that this was a different species besides prorigor. And I looked into the database in the game because the sizes that they give are, at least as far as I know, in the listed sizes in the game, roughly about the size of the model.
That, right?
And they actually do have, I think it's tab. So, well, you'll see before, I want to say this before we actually get to the actual thing, because you'll see something that I do want to ask about when we actually pull it up. So, but you can get to where you're going to click on Tylosaurus on there, if you want to, in the database, because there's a jump scare to it.
Heard chef.
So I was looking through here, and turns out that the size is, like, basically this animal is listed in the game as being bunker size. It's like 49, it's like 45, 46 feet long. Yep. It's like 14 meters.
Yep.
They have it listed as. But they have a very different, here at the Skeleton Crew, we are linear distance people when it comes to measuring the size of animals, but we are still biologists somewhat, and we do talk about how mass is important, and I want you to take a look at how heavy they say this thing is.
What? That is absurd. Actually,
is it? I don't know offhand. This is my secret. I don't pay attention to mass systems.
Well, so here's the thing. So we talked in the Dreadnoughtus episode last week about how you estimate mass, and the best tools for doing so are only for terrestrial animals, right? Because they assume that you're bearing weight through the long bones. I have 2 answers for this. One is, this is an animal about the size of a T-Rex. 14 meters is like a little bit longer than the largest known Rex specimen is. And the highest I've ever seen T-Rex's body mass is estimated is like 8-9 tons. This being literally twice as massive
strikes
me as a little bit much. But
close to 3 times some of the estimates.
No.
Well, yeah, it depends on the estimate. Like Rex has been estimated as low. Like it depends on your tools and which specimen. But like I've seen estimates as low as like 6 tons. Right, 6 to 9 tons would be my range of uncertainty. I'd veer toward the higher end of that. That said, Rex has an air sac system, which is going to reduce its density a little bit. It's got long lungs. And I don't know if we can really effectively bound the amount of muscular soft tissue on these animals, like without a preserved full body outline. Like they're kind of tubes. I feel like you could play a lot with the amount of soft tissue. 18 tons might not be as crazy as it sounds initially. I rescind my what, but
I think
I guess like 13.
Do we want to play a...
I would.
Oh, sorry, Amelia, you go.
Yeah. I would just say, like, I would guess that they're in the neighborhood of Rex because, like, even though they're longer, I think there's less animal there, but they are denser. So I think you're right. I think that they would probably be a little more than Rex, just because, like, they're solid.
Right. At 10 tons seems very reasonable.
Does anyone who's good at math, can anyone help me balance my budget?
Yes.
I'm spending so much money on candles and spending so
my
much.
plate is dying. Please help.
We can play a little math game of let's just see if we scaled a Komodo dragon up to this length, like how heavy it would be.
So what's a Komodo dragon at like 10
Like
feet?
a 10-foot Komodo dragon is about 70 kilograms.
70 kilograms.
Yes.
Let me pull up something on a croc as well, just to see, because it's more
scaling.
aquatic.
So we're making it 5 times bigger, right? Ballpark estimate. Square cube law states that as you increase the linear dimension by a factor, you square that factor to get the cross-sectional area or any sort of area measurement, and you cube that value to get any sort of mass measurement. So if it's 5 times larger, it would be 25 times the area and 125 times the mass.
Okay.
So 70 kilograms times 125 is about 8,000 or 8 to 9,000 kilograms. So about 8 to 9 tons, 10 tons, something like that.
Yeah.
Basically what we were saying.
That's more what I thought.
And
Yeah.
I will quickly just say the reason that I trust these numbers more than I would based on an aquatic animal such as, say, a whale is because these things are not built like whales. Like, they did not have whale blubber. We're pretty sure about that. Yeah, it's one of those things. It's a speculative thing that I wonder, like, if these things had more time on this earth, would they ever have gotten, like, because I think ichthyosaurs and plesiosaurs start to get a blubber-like tissue, right? Yeah. We don't have, to my knowledge, any evidence of that in mosasaurs, which I know we wanted to talk a little bit about the wiggliness of these guys. Like, I feel...
I just want to say really quick, because I pulled up the saltwater croc to see if it would be like significantly different, and it's for a 7-meter salty that's about 23 feet. That's roughly 1,200 kilos, which is 2,650 pounds.
So if you multiply that by 8, it's similar vibe.
Okay.
Yeah.
Yeah.
I mean, it's not exactly the same, but it,
I mean, this is
it
like
tracks.
Yeah.
Ballpark.
This is like the
Ballpark's
parking
right.
lot at the ballpark.
Right.
Yeah.
Just to, before we move off the blubber, just to...
Yeah.
So, are mosasaurs like exclusively pretty shallow marine animals?
No.
No, they're like ocean-going pelagic friends?
Yep.
Okay.
Yep.
I'm thinking like maybe... Right, because ichthyosaurs eventually, they look like, because they got those big eyes that they're like diving deep to catch stuff, so I wonder if that might have
There's plioplatycarpians. A couple of them look like goofy little bulldog animals because they have such big eyes.
Okay.
A lot of the Pacific taxa start to get really weird and like the big flippered thing, Megapterygius. Is that? Am I getting that right?
Sounds
it's such a weird name.
I think you are
I think
correct.
so, yeah. Megapterygius.
That
yeah.
sounds correct. Yeah.
Yay! I
That'd be-
reviewed
that'd
it.
be
I hope I'm
big
right.
Flipper.
It is Megapterygius,
I
yes.
reviewed it.
I know. I see the word in my head. I just needed to make sure I was saying. Yeah. So Megapterygius is the new mosasaur that was published. It's so cool. I love that specimen. It's so weird. When I first got the paper to review, I was like, "What the hell is this animal?" Because its flippers are so big. Like they're like this. Like they're huge. Which like this does look normal. Like this is the secret. Mosasaur flippers aren't actually that big. So this is more accurate actually to that thing than you might think. But anyways, the Pacific taxa are primarily mosasaurines and pliopletycarpines. They do some weird divey stuff. They do much more experimentation with like becoming ichthyosaur. Tylosaurs are very much if it ain't broke, don't fix it. They just get bigger. Like that is their trajectory. They're around through the Maastrichtian. Like they just get, with the exception of Tannivosaurus. Tannivosaurus kind of stays. That's the southern hemisphere one. They kind of stay small-ish and more slenderly built, versus the Tylosaurus branch gets like beefy. Like they're so chunky.
I remember hearing something very recently about like evidence of mosasaurs getting like the bends.
Yes, there is. In my research, I saw that too.
Okay. So to return to the flexibility and the blubber and all that kind of thing, I think there is some evidence of like stiffening tissue in the skin, which like makes sense, like because they're in the water, you have to deal with water pressure and all of that. But in terms of like actual mobility, like they're not stiff animals. At least Tylosaurus was not. There is evidence that they had like stiffening tissue in the skin, which makes sense given that water. It's to help keep the water pressure from squishing them as they are swimming. But they probably. No, not probably. They didn't have blubber. Lizards don't have blubber, and these guys didn't have time to evolve it. And there was a study, I believe it was a master's thesis in 2017 by Carpenter, that described the different vertebrae in different kinds of mosasaur with the goal of figuring out if it's actually specifically in Tylosaurus. I'm sorry, in Tylosaurus burger, with the goal of figuring out if the mobility of the vertebrae changed as the animals grew up. So, like, were the juveniles more or less wiggly than the adults, basically. And they found that it was, I think they found that, sorry, I'm looking right now. The juveniles were probably a little bit less wiggly so that they could swim a bit more fast than the adults were, I believe. Yes. But overall, they would have been chorangiform swimmers, which means that the propulsion is being generated from the hips back. It's not only focused in the tail, the tail-driven motion is called tuniform. So tuna looks like where all the motion is happening in the tail.
That's funny.
Yeah, or it's thuniform, but tuna. Chorangiform is more like a great white shark. Like they're mostly moving from the pelvic area back. Like there is still some flexibility up front, but most of the power is being generated back there. Versus
Anguilliform?
Oh man, what is it? Anguilliform, which is like eels, which are the whole thing is wiggly. In these guys, the whole thing was not wiggly with respect to when they are swimming, which we can, in this thing, like it's right, it's the hips back. They probably weren't moving the hips that much relative to the rest of the body, but like that's where the generation of the movement was started, versus some of the more derived mosasaurines, the movement is restricted to just the tail, so they were actually approaching like a tuniform swimming strategy.
Shakirasaurus.
Sure. So I think...
Can I ask a question about this?
Yes.
So my interpretation of this, I shouldn't say my interpretation because I haven't really thought about it a lot. Mosasaurs have a specialized... No, I mean, it's a question related to something I know about mosasaurs, but I shouldn't say it's interpretive.
Yeah.
So mosasaurs have a specialized vertebral region called the pygal vertebrae, right? These are...
Yeah.
Right. So these are, correct me if I'm wrong, posterior to the sacrals, but before the true caudals.
We don't know where the sacral is.
Sure. Okay.
Yes. So they are theoretically in the sacral region and ahead of the tail. And the difference is they don't have any ribs, but they also don't have any chevrons.
Right. So my interpretation of that, I guess, would be that that is the area that is being specialized for flexibility. Is that what's like inferred by this other research? Okay.
That's basically what's happening here. Yeah.
Right. So you're getting most of the flexion at the base of the tail then.
Yes.
Right.
And the other thing that like mosasaurines do that these guys don't do that helps to that suggests that they had a different swimming style is they have more accessory articulations for the rest of the vertebrae. So like in the cervicals and in the dorsals, like Cladastes being a good example of this. They've got zygaphenes and zygantra, which are basically accessory articulations that help to hold the vertebrae a bit stiffer together. Yeah. So now I think the only thing left for us to talk about is the soft tissue, which this gets mostly right, in my opinion, except for some details.
Yeah.
Yeah.
In my research beforehand on this, because I know that we have a really large sample size of mosasaurs, or of Mosasaurus in general and Tylosaurus specifically, and a lot of and one of the cool things about that big sample size is we have quite a few skin impressions.
Yep.
And those skin impressions seem to show that they had very snake-like skin and scales. And in fact, I want to highlight a specific part of I'm doing an Amelia impression. It's a quote from Oceans of Kansas, but
Good.
but it's specifically on the dermal covering of a mosasaurid reptile from Professor Snow from the University of Kansas. He actually puts it in a very poetic way, which I really like. He says, quote, Dana, in his Manual of Geology, 2nd edition, 465th page, speaks of the mosasaurs as, quote, snake-like reptiles. This comparison is strengthened when it is found that their dermal scales were almost an exact prefiguration of those of the rattlesnake, which infest the ledges within which these saurians are found. Which I just think that is a great way of phrasing that. But basically, it's like these guys had really, really tiny scales, like not just like small for the size of the animal, which they were, but also small just in general. That a square inch of surface contained over 90 scales, and like that's a ton. And they were all like small, again, very snake-like and keeled. And I think that this preservation has been good enough that some color work has been done on it as well, and at least shown that a portion, at least it's, I want to phrase this carefully because I screwed this up in our pre-recording, that a portion of the scales that were on the back were darker colored. And that has been interpreted as probably being the typical darker on the top, lighter on the bottom counter shading thing, but I do not believe that any lighter on the bottom has been found for Tylosaurus itself.
I find it very like, I'm not trying to drag you, Scott, or anybody, but I find it funny that we are saying like we know they're darker on the top but have no idea of anything anywhere else. Like maybe the whole animal was black. Like we know there is a dark color on the top. I want to restate my continued point that counter shading, to my knowledge, is not an adaptation for camouflage in any particular environment, but it is a consequence of the way that neural crest tissues migrate during development. Pigment is derived from the neural crest, which starts at the top of the body and migrates down, and you generally wind up with a lower concentration of pigment on the bottom side of the animal as a result of where it starts and where it ends. This is like, very closely correlated with a lot of the stuff about development that Amelia was talking about in the Mosasaurus video, where like the developmental origin and migration of cells matters quite a bit. So while counter shading probably does wind up playing a functional role in some contexts, I think it is interesting that both every paleo color study has found the animal was counter shaded. It's almost like this is a universal trend among animals, and not an adaptation that all of them happen to share. And that I don't think it necessarily has the paleo-ecological correlation that it's often purported to have. That is,
or just the ecological correlation in general. Because
right.
I've also been, for just a little peek behind the curtain into a look at James and my relationship, I have for a couple of years been kind of trying to disprove this for James. And like every once in a while, I'll just send him something of like, I think I found one. And then it's like, nope, that's actually like one individual animal or something like that. Or it's a weird situation or something. Like there's...
right. Animals are... You simply cannot. The only cases I'm aware of where there is no counter shading are individual animals where there is like... it's a uniform color. Right? It is the entire animal is colored the same, which is not incredibly common. I
thought I had something with some of like the like upside down fish, or there's like a couple upside down insects.
And again, I'm not.
And there wasn't.
Right, but also I think it's possible for an adaptation to be no counter shading, but counter shading seems to be the plesiomorphic state for everything. I mean, for a very obvious example, if you've ever had a tuxedo colored cat. Which side is the black on? Is it on the bottom or the top?
Well, obviously it's on the top because then it wouldn't be a tuxedo.
Hang on. Can I find it? Right. I'll see if I can get a visual aid.
Can you find a tuxedo?
Yes. Do you have a visual aid you could use?
Mine's not tuxedo, and he's on my lap, but he's also counter. Oh, he's running away. He's like, I'm not being filmed. Yeah.
At least.
Jesus Christ, he stinks. Good Lord, this animal. I'm sorry. This is...
The visual aid is simply snuggled too cutely and comfortably to drag him out here.
Maybe. Scott, if you were looking, like... Because I was thinking about this after having brought it up earlier, and I'm like, what would... And you know what, like, the best test of it would be? Are, like, pelagic crustaceans. Right? Because, like, neural crest-wise, they have to, like, develop like everyone else, right? The pigment stored in the balls, or whatever James said. Neural crest. But
I love that you listen to me when I talk, Alex.
Crustaceans, a lot of pelagic crustaceans, both in the fossil, probably in the fossil record, but that are alive today, swim upside down.
So there was the closest that I've gotten was that there was a marine snail that is habitually upside down, and it has on some individuals it's purple, if memory serves, that it has a purple, it has a like darker top that would like in life it would be the top, but developmentally it's the bottom, but like it wasn't as much of a smoking gun, and it isn't as strong or distinct as you would expect this to be. But I don't want this to be a stun line. Let's stop.
Isn't neural crest restricted to vertebrates?
Oh yeah, neural crest cells are, right?
Yeah.
I don't.
Your snails mean nothing.
He's right.
I also want to make the point briefly that just the descriptor of it. I googled this. It was just upside down purple snail, which sounds like it comes from a monster manual.
Oh, in the insane thing I'm doing that I just explained to Dalton, there are a lot of these. There's like a bunch of like pelagic invertebrates that have like basically all evolved the same color. It's kind of cool because they don't evolve the same color. There's like one thing that's this color, and then they all basically eat it. And so there are like a bunch of different groups of mollusks that are like the same shade of blue because they all eat the same little dude.
Huh.
But there's those cool snails that make like rafts of bubbles. To explain more, what I mean is instead of scrolling through Twitter at 1 a.m. now, what I'm doing is clicking every blue link on Wikipedia, starting at like prokaryotes, and now I'm somewhere in crustaceans because I'm trying to use my sleepy time to learn things about cool little dudes.
Yeah.
Well, anyway, did we talk about the tail fluke or?
Oh my god.
No, not yet. That's the next thing.
Yeah, we're done with college.
My dinner arrived 30 minutes ago. I'm so hungry. Can we talk about the tail fluke?
Yeah, we got to wrap this up.
Well, let's wrap the scales. They're wrong on the animal.
Right, they are. Right.
Because they're round, which is sad. But here's the thing: is from a distance, I don't see it, and the texture looks right. So
they're also way too big.
They're also a little too big. Yeah, I mean, it depends on the specimen. Some of them aren't teeny tiny, but it depends. And then the other thing I'll say about color is there's a gorgeous platycarpus in LA that I believe they pulled differences in pigment out on the face, and it had like a stripy pattern. which is
That's really cool.
Yeah, cool if true. It's a paper that I've like glanced at and I haven't internalized, but it always gets brought up when people are talking about mosasaur patterns and colors and things.
That's extremely
But
cool.
anyway, yeah, it's super cool. We can talk more, I think, about mosasaur colors in the Mosasaurus video, because I think there's more to say. Well, there's less to say about like the science because I haven't spent as much time working on them. But anywho, the last thing is the tail fluke. So that is based on a fossil of Prognathodon that was found in Morocco and published in 2013. That's another structure that I don't know if it evolved multiple times or not, because we only have one specimen that has the actual like soft tissue outline.
Mm-hmm.
In Tylosaurus and in Platycarpus, like there's a little bit of osteology going on that might suggest that that's where a tail fluke would be, but it's not as distinct as it is in the Mosasaurians, which makes me wonder. And there are some folks that are against giving Tylosaurus tail flukes for this reason. However, there is definitely something weird going on in the tail, and I think they did have one. It's most apparent in the AMH specimen because it's mounted as it was found. Like that specimen is incredible. It's immaculate. It's mostly complete. If you get a chance to see it, you should. It's beautiful. But in the tail, the curve that it has, the curve going downward, like is real. It's not just the tail was curved that way. That's a structural curve in the tail, and that's shown here. So the bony part of the tail in the fluke in a mosasaur is going into the bottom lobe, and so that's what that curve is. So that has the curve, and then also at about that point in the vertebrae, the neural spines change shape a little bit. So they generally point backwards, and then at that point they kind of kick up and then point forward a bit, and then they go back to being normal. And it's really, really subtle, but like it is there. And that kind of part where they're kind of coming together and facing up is what would be supporting the tail fluke, because that's what we see in the Prognathodon that actually has the outline. And the last soft tissue thing I'll say is about the flippers. This one shows the edges as mostly smooth. Again, we don't have a Tylosaurus flipper outline, and because flipper shape is very different in the different kinds of mosasaurs because they evolve flippers differently, I don't know if we can trust the Prognathodon because it's a mosasaurian. But at least in Prognathodon, it seems to actually have a little bit of scalloping. So there was actually a little bit of differentiation between the fingers, which is kind of neat. Again, whether or not that's also present in other mosasaurs, I don't know. Especially because, again, the flippers have kind of evolved a couple of times in these guys. And Tylosaurs have really long fingers, like really long kind of spread out fingers. So I don't know, because I don't think there's a strong correlate for this. And I mean, all whales have smooth flippers, basically, so it's not like we can really use them to help. But there's variation in how their digits look, so it's not super helpful.
Amelia, can I ask a question before we wrap up this segment? The change in the orientation of the neural spines in the vertebrae, correct me if I'm wrong, but that was also the evidence in favor of the presence of a dorsal fin in Megapterygius, right?
Yes.
And I know that happens in cetaceans, where the dorsal fin is.
Some cetaceans, not all.
One cetacean. Okay.
I think a few,
yes.
not
so
many.
We can talk about Megapterygius in the Mosasaurus episode because it's a mosasaurian, and it's a very interesting specimen. And the long story short is it's a different kind of change of shape. Okay. So in Tylosaurus, it's the entire spine. In Megapterygius, it's like there's an angle. Like they do like this. It's weird, and so that's why if it's real, that would be cool, and it would be like, okay, I take that as good enough evidence if there's a second one. Basically, we need another specimen. There's only one right now. So it's hard to say really if those spines are actually just broken taphonomically or pathologically. But that said, I do know at least the lead author on that paper, and I generally trust his interpretation of anatomy. Like he's got a good eye for things. So I want to believe him when he says that it's real and not busted up, but like it is so hard to see from photographs, and it's so unlike anything else we've ever seen that it's odd. Like I'm not, and again, I'm not saying that it's wrong. It's very, very odd. And I hope that there are more specimens that help solve that. If it's just a one-off weirdo, or if that is a real feature.
Right.
Because if it's a real feature, if we get a second or third one, that I think is much more compelling. But yeah.
Okay. Well, is it time to rank Tylosaurus?
I think it might be time to rank it.
Let's do it.
It is.
Indeed, it is.
I need to
He's about
briefly.
ram into the wall.
I'm sorry. I need to briefly vanish while we change over. I'll return.
Yeah.
That leaves me time to say the phrase that came to mind, which we can cut out. And the other thing is, there's a lot of great options for color. I'm going to do this one because I like it the best.
See, I have.
That's great.
I have a bit. I have a bit of a weird hot take when it comes to. Not even a hot take. I have a strange personal preference when it comes to the Tylosaurus skin specifically. I'm not a big fan of how they do the stripes on this. It looks very like.
It looks spore.
It looks like the goofy tiger model that I.
It looks spore. It looks like what every kid does when they're drawing dinosaurs and just do little like triangles on the back and stuff. So I'm not a fan of it. This is one of the few animals in the whole game I do not put a pattern on when I put it in my parks. Because it's like, hey, it looks more naturalistic to me. It's like, hey, big lizards and big reptiles just
tend to be plain.
Right.
plain.
Well, Amelia, why don't you give us your first ranking on the creature?
All right. It's so ugly. I love it. Like, I don't remember what... No, I think I remember what I gave it. Like, obviously, the anatomy is horrific. Like, that is not what their skulls look like. And, like, I was... Like, yes, there is a busted up one that answers the first part of the face, but the entire back half of the skull is messed up. The jaw's at the wrong angle. The jugle's at the wrong angle. Like, it's horrible. That said, it has character, and I appreciate that. It looks like a Tylosaurus that was made to be in this franchise, in my opinion. But it was also like they put time and effort into giving it a texture that actually looks pretty good, even though it's not quite right. Like, from a distance, it looks great. It looks, like it has small scales, which is correct. The tail fluke is great. The overall proportions, aside from the flippers, the front flippers being too big, it looks great. It moves great. I like him. I'm giving him an S for sin, because that's how we opened this video. That's what these animals did when they were alive. But also, I think, like I said, it works for me as a design, as a character, as a characterization of a Tylosaurus. And it's like, he looks like a piece of shit. And they were so mean. I love them very much. Don't get me wrong. I've gotten
slick back real good.
Sure. Yeah, no, I like it. I may be biased, but I like it.
Okay.
I'm really torn because I can internally justify arguments between B and S for this animal.
Well,
There's
it
a
sounds
rank
like
between that.
There is,
Yeah.
but I don't want to default to that because I feel more strongly about the end members.
Okay.
On the one hand, it's something I do frequently put in my parks when I play the game. I like it but I think that's more of a gameplay thing because it doesn't have a huge space requirement and it's very popular. I think it helps when I'm doing a challenge mode. I like that they included a second mosasaur in the game. I like that they clearly did some research about them to try to make this one at least have more details right. I find the anatomy ugly enough that I don't think I can give this anything higher than a B. I don't think that the anatomy being ugly is a bad thing per se. It looks great as a busted up, gnarly, really old, mean animal. It's a good character design, but I just feel like with how much we know about mosasaurs, I would really love the game to have one that is I don't know, more anatomically accurate. Right, when I have to put a mosasaur into my parks, I usually go with the Jurassic World Mosasaurus, even for all of its inaccuracies, because I just find it better looking aesthetically. So I think I'm going to go with the B.
I'm going to echo some of these thoughts, but I will really double down on this thing is a vibes and flavor win. this gives like the aesthetic of how like this has kind of become how I sort of picture Mosasaurus in my head, just because it is hideous, but in a very realistic way, like, or in a very authentic way. Let's put it that way. That like, as opposed to some of the other hideous animals we've had on here, like the Pyroraptor and the Deinonychus, those things just look like bad models or affronts to God and nature. But this one is still an affront to God and nature.
Yeah, I was gonna say that.
Let me not be misconstrued here. This thing shouldn't exist, but it feels like the way that it shouldn't exist is more plausible, if that makes sense, which it doesn't. But especially the biggest thing I like is I love its snaggle teeth. I like that it's just gnarly looking. That's the biggest thing, gnarly. I do have like one tiny little question before it doesn't affect my ranking. It's just something I've noticed on the model. What are the little I guess more knobs that it has on its jaw? It has like a little like double ridge of them going down there, and I don't know what those are, and I don't think those are on Tylosaurus.
Where? What are you looking at?
On the jaw,
let me see
on
if I
either
can
side.
spin the light.
See how there's like
General Grievous when he's in a tricky
so
situation.
Like these bumpities.
Oh,
It's like there's like 2 rows of bumpities going down.
boom, boom, boom.
No, I've never noticed those before.
Yeah, I only noticed them today.
No,
as well.
I interpret that as like pathologic grossness. They don't have any. They don't have any ornamentation.
Weird. Yeah, they're extra knobs. This is the knobbiest of the knob lizards. But
The Knob Lord.
The Knob Lord, and I will give the Knob Lord an A. I wish that the front flippers were a little bit better. I do wish that, even though it is a nice for a pathological beat to mosasaur, I would like it. I would like the animal that it's been given 5 names in history, and 3 of them are referencing that it has a big nose. Like, give the animal its nose. That'd be neat. So, yeah, all right, A. But vibes are great, and by that they are rancid, but appropriately.
I don't know. I like it. It looks more like the actual animal than the other one does. I'm fond of it. It's got, and I think I'll save this more for the Mosasaurus video, but there's like there's Amelia alluded to it when she was kind of introducing Mosasaurs, but there's like this 20-year period before anyone knew what a dinosaur was, where like the entire knowledge of Earth's prehistory was like this swampy, sleepy, like Noachian deluge was just the entire world, and it was just horrible, big, like world serpents living everywhere, and they kind of evoke that for me. So this is an A. It's not exactly what the modern animal would look like, and there's some weird kind of unaesthetic choices that keep me from saying S. So I say an A.
Yeah, I echo what has been said. This design's really cool. I like it a lot. And I do also tend to put it in my parks. And like James, it's a great aquatic to put in your park if you're doing the challenge modes, because it's a small space but a lot of popularity. So pro tip for people who actually play the game. It makes it makes a few too many aesthetic choices that I don't think are like wrong choices to make, but I don't personally like them that much. Like, the size of the flipper really bugs me because it makes me think of like a betta fish a little bit. And the flipper has these like grumbledy bumps on the front, which messes with like the hydrodynamicness of it. The tail the fluke has like these grumbledy bumps on it too that I don't love. And again, I think it adds to the gnarly appearance of it. I understand artistically why those choices were made, and I don't fault the design for it. It's just not to my taste. And then, yeah, my biggest the biggest thing for me is that even knowing about the Black Knight, which does look shockingly like this, if I was to have a model of a Tylosaurus in a game, I would prefer it to be not one that got completely up by another Tylosaurus, or to have like wounds be a thing, and like if they fight, they can come out and look weird. Like the game doesn't have that mechanic, but it does have wounds. I would have preferred if the profile of the skull didn't have an underbite, just because of the really prominent point that you see on like nice Tylosaurus skulls. It's like it is the animal, and it is aesthetically also really pleasing. Those are what's keeping me from putting it in S, because otherwise I really love the design, and the colors are great, the behavior is really cool, but it's an A for me.
So I think that puts Tylosaurus in A tier.
Yeah.
So with that, Tylosaurus joins Albertosaurus in A tier.
Nice.
Hooray!
Yay.
Hooray!
And now
It's time.
The
It's
first
time.
of the
it is
year.
time
Oh,
Yes.
the first. Yeah.
Yeah.
All right. First wheel spin of 2024. What will it be?
to
Spin.
Spin.
Sorry.
That. Wheel!
Yay.
Have fun ending that.
Yeah. Oh, it's
Oh
Thanks.
no, we're keeping the theme of up
Oh, Liopleurodon.
It's
Oh,
Leo
dear
Pleurodon.
God.
Oh no! Cool. That'll be a fun episode. That's certainly a choice.
Yeah. Okay. Well, the less said about this animal, the better.
Ooh.
Yeah. Well, we're
that's
probably
a
going to have a lot
terrible
to say about it next week. Anyway, we're going to wrap up the video now.
Goodbye.
Thank you all so much for watching this installment in our series. I think we had a great discussion about Tylosaurus,
Yeah.
and I think you guys are privileged to have gotten to see it. I'm very tired and drove for 12 hours today, so I'm going to limp through all my thank yous. Please like, subscribe, comment, support us on Patreon if you can. Remember, we sell merch on Redbubble. I keep forgetting about that, even though I put it in the description of all the videos. But you
And
should
Amelia and
remember-
I are working on some new merch.
Yes, they are, and it's going to
You'll
be
see.
great.
It's gonna be.
We have
But
some really
Pretty
good
cool.
ideas.
I want to give a special thank you to our patrons. And unlike in normal episodes where I read you all in the order that Patreon shows you to me, I'm going to specially highlight our 2 Tylosaurus tier patrons because this is the video about Tylosaurus. And those are AK92 and Christopher Bellis Jones. Thank you very much for supporting us at Tylosaurus tier.
Thank you.
The rest of our incredibly generous patrons in Gorgosaurus tier or higher are Benjamin Siepser, nickname 3110, Philip Fico, Adamolos, Dan Okiris, King Zashu, Lax Fishin, Max Ironpaw, original username, Pythonic, Swamp Ape Science, and Wheat. Thank you all so much for your support of the Skeleton Crew. All of your support means a lot, and it really helps us keep the content coming. We are really looking forward to what we have in store for this channel in 2024. This is the first video we've recorded in 2024. So this is really exciting for us. We're officially in the second year of the Skeleton Crew as a channel, and we are amazed at how much we've grown so far and are really excited to see what we can do in the next coming year. So thank you all so much, and we'll see you next time when we talk about the only animal in this game with a neck beard, which is Liopleurodon.
Oh boy.
Oh
Also,
boy.
And viewers, if we have Alex fans in the audience, you might be like, man, this episode seems light on Alex, and that's because I made a lot of very funny jokes that were unfairly cut, and I'm being censored. So I'm starting my own channel. You can follow me on what's right wing YouTube called.
All right, we're wrapping the video. Good night, everybody.
Counter
Bye-bye.
Strike.
Bye.
Bye.